Hi there, welcome back. In this video we're going to talk about making mechanical mates in Solidworks. Mechanical mates in Solidworks are meant to help Solidworks model what actually happens in mechanical connections in real life. So for instance, a good mechanical connection is two gears interfacing with each other, or a screw, or a rack and a pinion. And Solidworks has mates to make all of these happen. So I'm going to go ahead and create a new assembly to demo this for you. I've downloaded from GrabCAD a rack and a pinion, and I'm going to go ahead and start my assembly. Oops, and I accidentally made a part instead of an assembly, so let's go ahead and do new assembly. And I'm going to go ahead and input, actually I'm going to start by inputting my pin, okay? And we'll go ahead and open that guy. And there's my pin. Alright, and the reason I'm doing this is because I want to locate that pin in a particular spot, and then I'm going to use that to locate my pinion gear here. Alright, so I'm going to make this first pinion gear, I'm going to mate that to be concentric around the pin. So this is just making it so that the pinion gear is going to be able to spin but is fixed in space. Alright, and I'm going to mate it so that it stays right there. So there's my gear, it can spin. Now I'm going to hold Control and drag. Oops, let me get out of the mate command first. Control and drag, and that inputs another instance of my pinion gear. Alright, now what I really want to have happen is I want these two gears to mesh together. And so what I'll do, first I'm going to mate them so that this surface and the top of the tooth here are tangent. Now, in good gear design, you would actually go ahead, and that isn't the correct way for putting gears together, but for now it'll be a good basic way to do it. You're going to want to read a machine design text or something like that to actually learn about how you space gears properly, their diametral pitch, and so on. That's outside the scope of this class. We just want to learn how would we put gears together so that they would mesh and interface. So right now I have these two gears and I can spin them independently, but what I really want is I want them to interface with each other. So for now I'm going to go ahead and put another mate on here to make those two faces coincident. Okay, and you can kind of see this guy's spinning around the other gear. Now I want to add an advanced mate. I'm going to delete these two surfaces and come down here to mechanical mates. And you can see in mechanical mates we have a bunch of different options, and I want to demo for you the gear option. To use the gear, you need to select two round surfaces, and the ratio of their diameters sets the gear ratio. In this case, I could choose, maybe I'll choose this surface right here. It's a round surface, and I actually choose the edge. Okay, I'm going to choose the edge here as well. Alright, and it doesn't like that, so let's actually undo this. And I'm going to have to delete real quickly my tangent mate here, okay, because I was over defining. So I need to undo that mate, and then I'm going to try it again. So I'll hit Control there and Control here, these two edges, and then I'm going to click on Mate, and I'm going to come down. Instead of doing coincident, I'm going to open mechanical mates and I'm going to click on gear. Alright, and you can see that it sets the ratio, and those two surfaces have the same diameter, so the ratio is 1 to 1, and we'll go ahead and click check. Now watch what happens when I spin my fixed gear. The other gear spins with it and they stay meshed. Alright, so pretty handy tool there. Now it may be, see how my gear is moving all over the place here. I probably actually want to go ahead and put a mate on this to get those coincident with each other. So that's a standard mate. Go ahead and say coincident. And now my gears, right, when I spin this gear, it just spins the other one at the same ratio. Alright, maybe, however, I don't want them to spin this way. Maybe they aren't actually in mesh. Maybe they're separated by some distance. I can make that happen. So if two gears are in mesh, they are counter-rotating. But if they're on a belt, which is oftentimes how we would do stuff, if they're on a belt, then we need to change and just check this reverse box. Alright, now that is going to link them together so that they spin in the same direction. Alright, pretty handy there. I'm going to delete my coincident requirement here, and I want to show you another type of mechanical mate that we have, and that is the screw mate. Okay, so let's say that I actually want this guy to move in and out as it turns. I can make that happen by applying a screw mate. So if I go to mates, and it's not a standard mate, it's a mechanical mate, and I click on screw. Okay, what I need to do is select a surface. If I come up to the top, I have to select two things. I'm going to undo the edge here. I select a surface, I select the cylinder, and then I'm going to go ahead and select an edge along which I want that screw to run. Okay, so I'll hit check, and now as I spin this, oopsies, I think I undid too many mates here, so let me get out of this and look at my mate here. Let's do it just with one screw. That's going to make more sense here. So I'm going to go ahead and actually delete my second pinion gear. Okay, and I'm left just with my gear on the pin. All right. Now what I'm going to do is I'm going to delete the coincident requirement that makes it stay where it's at, and I'm going to add a screw mate. The screw mate looks for two things. It looks for the cylinder that's and you could think of this as the diameter of the screw, and it looks for the edge that you want it to screw along or in comparison to. Okay, so now as I screw this, see how it moves in and out? Watch as I spin it, it's moving in and out at a given ratio. Okay, and that ratio is governed in the mate, so I can set this screw up so that it screws in and out just as it would if it were a bolt unscrewing or screwing. And so if we look at that mate, you can see you can set revolutions per inch or distance per revolution. Alright, and you can change how that works. So that's the screw mate. Alright, I also want to show you how a rack and pinion mate works, and to do that I have to insert a rack. So I'm going to go ahead and insert rack. Okay, and here I'm actually going to go ahead and make my rack fixed. So I'll right click on it and click fix, and I'm going to delete my screw mate so that I can put the face of the pinion and the face of the rack, I can mate those to be coincident. Alright, so now it's stuck on there, and what I want to show you, I have this guy spinning, and I want to show you that you can actually drive the rack based on the revolutions of this guy using a rack mate. And let's go ahead and actually I'm going to float the rack again. Okay, and instead of making it fixed, I'm going to make it right now it can move around. So now I'll go ahead and add my mate for a rack. So if I come down, do mechanical mates, and I should undo my selection. Click on rack and pinion, and what it asks for in the rack is what's the direction of the rack, which I will choose kind of the base of one of the teeth there, and then where's the pinion gear. And for that I'm going to choose again an edge, okay, and it's the edge out at that outer diameter, and it automatically then tells me the distance, the pinion pitch diameter, which is 4.409 inches, and it sets up this rack so that now when I spin this, see how the rack moves. And let me put a mate on this so that it's not moving all over the place for us. I'll make it coincident. Okay, so now when I spin my gear, that rack gets driven at the appropriate rate. Okay, so that's the rack and pinion mate in Solidworks. Alright, that's just a quick intro. We looked at gear mates, we looked at screw mates, and we looked at the rack and pinion. There's also slot and cam, very useful mates. Go ahead and explore those on your own. Thanks so much.